Microsoft researchers just released a paper claiming that GPT-4 is starting to show sparks of artificial general intelligence. In just a short time since OpenAI released GPT-4 out into the wild, researchers have already found GPT-4 already much more capable than previous generations. Hey, welcome to Chaos Theory, a space where we find the signal and the noise and all that's happening in AI, tech, and life. I'm Alex, your resident chaos coordinator. If you like content like this, be sure to like, subscribe, and hit the bell icon. And leave a comment for what you'd like to see next. Alright, let's begin. Alright, so researchers at Microsoft released this paper, Sparks of Artificial General Intelligence, Early Experiments with GPT-4. If you remember from one of my previous videos, I talked about OpenAI and their roadmap to building AGI. They published a charter explaining how they would release new generations of AI models, and GPT-4 is the latest one of them. So in this paper, researchers defined intelligence as a very general mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. And in the paper, they report that a new large language model developed by OpenAI, which was the early non-multimodal version of GPT-4, meaning that it was the one that did not have the ability to ingest images, that this model exhibits many traits of intelligence. They say despite being purely a language model, this version of GPT-4 demonstrates remarkable capabilities on a variety of domains and tasks. This includes abstraction, comprehension, vision, coding, mathematics, medicine, law, understanding of human motives, emotions, and many more. In some of these examples, you see researchers test to see if GPT-4 can write a proof that there are infinitely many primes, where every line is a rhyming one. You also can see GPT-4 being able to draw shapes and figures using a specific formatting language called TIC-Z. Remember, this is an early version of GPT-4, a model that's trained just to predict the next word in a piece of text. So the fact that it's able to draw this complex image and render it into this diagram is quite impressive. Some of the other things that they test is whether GPT-4 can generate plots using data. You see here images of plots that were generated by the code produced by GPT-4. They also tested GPT-4's mathematical reasoning ability. So we see here functions of inputs and outputs, and it being tasked to apply that function multiple times. It's also able to explain its reasoning about how it got to that answer. So even though GPT-4 is excelling at several of these tasks, the researchers do point out that the patterns of intelligence that they see are not really human-like. But they do acknowledge that GPT-4 is certainly a first step towards reaching increasingly intelligent systems. This leads them to make the bold statement that GPT-4's intelligence signals a true paradigm shift in the field of computer science and beyond. Some of the ways that they've seen this play out in a real practical setting is seeing GPT-4 passing mock technical interviews on LeetCode. You may have seen some headlines of GPT-4 being able to be hired as an entry-level software engineer just by passing these coding exams. At the same time though, you can see some limitations in its output. In this example, the AI is being asked to get to McDonald's from the SeaTac airport. While giving a confident sounding answer, it's technically not correct. However, the generation capabilities, especially in a creative field like art, are quite impressive. We see here both GPT-4 and ChatGPT being able to produce JavaScript code that can create a random image that looks like a painting by the artist Kandinsky. They do note that a key measure of intelligence is the ability to synthesize information from different domains or modalities, and the capacity to apply that knowledge across different contexts or disciplines. So how does GPT-4 actually do this? Well, we see that the model is actually able to combine different skills and concepts and show an actual innate comprehension of complex ideas. You can see some of the examples of pure generation of graphics that GPT-4 is able to produce. But in a more complex scenario, you can see the additive capabilities that GPT-4 is able to produce, taking direction from human feedback. So here, GPT-4 started by creating a very basic image, following the human's instruction. But then when the person said that they needed some corrections, you can see GPT-4 actually applying these things. And now when they wanted to add a shirt and pants, well, GPT-4 was able to do that as well. And in a similar scenario, you can see GPT-4 being able to combine, compose, and synthesize different pieces of information to ultimately achieve a desired result. So here, in a similar thing, they're being tasked to create SVG code to produce this image. But for each of these, the model is tasked with not only generating the object, but also to do it in the style of a letter. So this combination ability, being able to synthesize different directions, is one of the key features of GPT-4's intelligence. To illustrate this a different way, we can see how GPT-4 compares with Stable Diffusion. So Stable Diffusion, the popular image generation model, by itself is able to create this image using this prompt. GPT-4, on the other hand, again, purely a text-based model, is able to create this sort of vector graphic using this prompt as well. And now when you combine these two, using GPT-4's sketch and putting that into the Stable Diffusion pipeline, you're now able to get a more comprehensive result. But what about for music? The authors note that some of the data that GPT-4 was trained on contains several musical pieces of information that was encoded as ABC notation. ABC notation is a text-heavy system that uses letters, numbers, and symbols to represent musical pitches, durations, chords, and other elements in a compact and readable way. So what the authors did was take GPT-4 and instructed it to generate a short tune, and the model was able to actually produce valid ABC notation. They found that the tune had clear structure, the time signature was consistent between bars and notes, and followed increasing and decreasing patterns. The tune also had several notes within the melody, and the rhythm had a repetitive pattern. One thing to note though is that the model by itself did not seem to obtain the skill of understanding harmony. So we can see here GPT-4 creating a short tune using ABC notation. So we see here GPT-4 creating a short tune using this ABC notation. And then following, we now see GPT-4 being able to explain the tune in musical terms. And then in a bit of back and forth, the authors are able to refine that tune to make it better and to rewrite it in a form appropriate for a duet. You can see here the sheet music of that final tune. And beyond music, the authors pushed the boundary to how much GPT-4 could write code. In this case, they tested whether they could create a 3D game in HTML and JavaScript. They also asked GPT-4 if they could write some code for machine learning. In this case, they compared GPT-4 and ChatGPT, implementing a custom PyTorch optimizer module. And in just this section, they see that GPT-4 is actually able to be more astute than ChatGPT and correct its mistakes. Another big measure of intelligence that we test our students and people alike is the ability to do math. So the authors wanted to see if GPT-4 could apply quantitative reasoning when facing problems that require mathematical thinking and model building. While they found that GPT-4 was quite impressive, it was still quite far from the level of experts and didn't have the ability to conduct novel mathematical research. One thing that they point out, though, is that actually interpreting the results is a nuanced exercise. Some might just look at the final answer and say that if it doesn't match exactly what they expect, the model lacks true understanding. But we don't always test our students this way. Oftentimes we give students partial credit if they can explain how they arrived at their answer and show their thought process. In a similar way, the authors break down GPT-4's mathematical abilities into these various subcomponents. They argue that mathematical understanding has several aspects. 1, creative reasoning, 2, technical proficiency, and 3, critical reasoning. Creative reasoning, they say, is the ability to identify which arguments, intermediate steps, calculations, or algebraic manipulations are likely to be relevant at each stage of a computation in order to chart a path towards the solution. This part is often based on a heuristic guess, or in the case of humans, intuition, and they say it's considered to be the most substantial and profound aspect of mathematical problem solving. Technical proficiency is effectively being able to follow a formula, performing routine calculations or manipulations that follow a prescribed set of steps. Critical reasoning, though, is the ability to critically examine each step of the argument, break it down into its subcomponents, explain what it entails, and how it's related to the rest of the argument and why it is correct. These 3 steps, creative reasoning, technical proficiency, and critical reasoning, are what the authors say are key aspects of mathematical understanding and reasoning. For GPT-4, in the area of creative reasoning, they found that the model demonstrates a high level of ability in choosing the right argument or path towards the solution. So while it might not always get the right answer at the end of the day, the fact that it's often able to choose the right path shows that it does have some ability to reason creatively. However, in the areas of technical proficiency, GPT-4 struggled. The authors found that the model made several mistakes when performing arithmetic and confusing the order of operations and using incorrect notation. So this lack of precision and technical proficiency is one of the areas where future models can definitely improve on. One big other area that GPT-4 struggles is in critical reasoning. A lot of this can be attributed to the training data. The data that GPT-4 and other models were trained on consisted only of questions and their solutions. However, the wording did not always express the actual thinking process that went into the solution behind the problem. So the fact that these models lack this inner dialogue is one area where these models differ from how people normally solve problems. So in this example, researchers asked GPT-4 to come up with a mathematical model for profiling the physiological power rate over time of a professional StarCraft 2 player during a match. They made sure to ask the model to account for the player's actions per minute and the race the player plays. Compared to ChatGPT, GPT-4 was able to create a more comprehensive answer that required the use of extensive interdisciplinary knowledge. They also posed several specific type of mathematical modeling problems called Fermi questions. These Fermi questions involve making educated guesses about quantities that are difficult or impossible to measure directly. Think of Fermi questions as being similar to the case study interviews that you would get if you were applying to be a management consultant, investment banker, or product manager. So the example that they provide, they asked GPT-4 how many NVIDIA A100's GPUs there are in total on Earth. Compared to ChatGPT, which wasn't able to provide an answer, GPT-4 was able to make several assumptions, break down its reasoning, and ultimately give an answer. One other area that the authors explored was GPT-4's ability to make use of tools. Because GPT-4 and other large language models have weaknesses in their lack of current world knowledge, difficulty with symbolic operations, and inability to execute code, the need to hook GPT-4 with external tools is critically important. That's why we just saw OpenAI announce the use of plugins inside ChatGPT. So for example, being able to query a knowledge store like a search engine or make use of a calculator are important tools for these large language models to give you the ultimate correct answer. In this example, they show GPT-4 making use of various tools to answer questions. In this prompt, they said that if the model needed to search the web, they could use the search function, or if they needed to run calculations, to run the calc functions, or to get a specific character from a string, to call this character function. So what they saw is that GPT-4 is capable of both identifying and using external tools on its own in order to improve its performance. Inherently, the model is able to reason about which tool it actually needs, and all this is done without any specialized fine-tuning or training. However, they do note several limitations. GPT-4 still actually requires the prompt to specify that it's allowed to use these external tools. Without such a prompt, the large language model would be lost. And sometimes GPT-4 is not always able to reason about which tool it should use and when it should use it. However, on its own, without any additional human feedback, GPT-4 was not always able to reason about which tools it should use and when it should use them. But simply asking the user for more information boosted the model's power of interactivity. However, they note that humans don't communicate through APIs. People use natural language to communicate with one another, explore their environment, and learn from the consequences of those actions. This is called embodied interaction, and it requires the agent to understand the context, the goals, the actions, and the outcomes of each turn of interaction. This is called embodied interaction, and it requires an agent to understand the context, the goals, the actions, and the outcomes of each turn of interaction and to adapt accordingly. To explore embodied interaction, the authors tasked GPT-4 with being able to summarize what it sees as it navigates through a map. You see GPT-4 being able to make use of this information and imagine what rooms look like based simply on their names and connections. And when actually diagramming what this map should look like, GPT-4 is actually able to do it pretty well. One other big piece of intelligence is being able to interact with humans, and with interacting comes understanding. The authors call out the theory of mind, which is the ability to attribute mental states such as beliefs, emotions, desires, intentions, and knowledge to oneself and others, and to understand how they affect behavior and communication. A lot of this is being able to reflect on someone else's mental state, like asking the question, what does that person believe? For intelligence researchers, theory of mind is essential for being able to effectively communicate and cooperate with other intelligent agents, because it allows one to infer their goals, preferences, motives, and expectations, and to adjust one's own actions and what they say accordingly. So they include several modern tests of theory of mind, like the Sally Ann false belief test from psychology. They also make use of this other test to see GPT-4's ability to reason about the emotional state of others in complex situations, like why people do certain actions and what people think are the causes of those actions, as well as exploring intent or how people received comments or feedback, and explaining why they're not making progress and suggesting ways that they can improve their situation to reach agreement. So what they found is that GPT-4 has a very advanced level of theory of mind. Compared to ChatGPT, which also does pretty well in some of these tests, they found that GPT-4 was more nuanced and was able to reason better about multiple actors and how various actions might impact their mental states, especially on more realistic scenarios. One thing that the authors call out though is the limitations of the autoregressive architecture of GPT-4. This architecture is reflected in the core training procedure of being able to predict the next word in a sequence. To predict the next word, an intelligent agent would need to rely on working memory and often requires planning ahead. So in this example, they asked GPT-4 to merge the content of the next sentences into one sentence. So just think about it. In order to complete this task, you would need to read this entire paragraph, decompose it into its core ideas, and then synthesize that into one single sentence. A normal human would have to backtrack or make edits a few times before reaching the final answer. But GPT-4, because it's predicting the next most likely word in the sequence, is not able to do this sort of backtracking. Because of this forward nature of GPT-4's output, the only way for the model to do such planning is to rely on its internal knowledge and representations and parameters to solve the problems that otherwise might require more complex thinking. They also show an instance of GPT-4 coming up with the wrong answer, like when asked how many prime numbers are there between 150 and 250. GPT-4 confidently says that there are 13 prime numbers, but when you actually list it out like what GPT-4 does in this other prompt, you're actually able to get the correct answer. So this shows that the model does have the sufficient knowledge to answer this question, but sometimes it requires extra direction in order to get there. This inner dialogue or chain of thought reasoning that we humans naturally do when solving problems is a big step for allowing GPT-4 and other models like them to do a lot better on these tasks. One analogy that the authors use to illustrate this is in the popular book, Thinking Fast and Slow. Fast thinking is a mode of thinking that is automatic, intuitive, and effortless, but it's also prone to errors and biases. Slow thinking, on the other hand, is a mode of thinking that is controlled, rational, and effortful, but it's more accurate and reliable. Human intelligence and cognition, then, is a mixture of these two modes of thinking. GPT-4 in its current form can be seen as only applying fast thinking, but sometimes it needs to be prompted to do more slow thinking. So while the authors do note that GPT-4 is quite capable already, the authors do note that there are several steps that they can take. The authors do note that there are several steps that OpenAI and other model creators can take to make these models really approach true artificial general intelligence. One of them is being able to deal with hallucinations or to calibrate the confidence in the response of these models. Sometimes these models can be sure that they're right when in actuality they're wrong. They note that several ways to improve this is to calibrate the model either via prompting or fine-tuning, or to also just insert the information that the model lacks directly into the prompt. Another area that the authors say is necessary is in long-term memory. Because these models are effectively stateless functions, there's no way to actually teach these models new facts. This illustrates the challenge of continual learning. The model lacks the ability to update itself or adapt to a changing environment. Because it's fixed on the data that it was trained on, like ChatGPT being only trained up to data from 2021, there's no actual mechanism for incorporating new information or feedback from the user or the world. One other area is in personalization. Some of the applications that these models could be used for require customization to a specific organization or end user. This requires knowledge that only that user or enterprise would have, but not available to the broader public. So in this way, the models need to be able to have some mechanism to incorporate personal data so as to make them feel more appropriate to the end user. Additionally, the model needs to plan and make conceptual leaps, be transparent, interpretable, and consistent. The model also needs to correct several cognitive fallacies or irrationalities that might be reflective in their training data. They also can't be sensitive to the sort of inputs that they receive. But despite these limitations, the Microsoft researchers agree that GPT-4 represents a big step towards achieving artificial general intelligence. Maybe by the time the next GPT models come out, we'll be that much closer to being in a brave new world. It's certainly going to be fascinating to see, especially as more people uncover new capabilities inside these large language models. I, for one, am super excited, and I'm looking forward to continue building in this space. So to building that future together, here's Alex, your resident chaos coordinator.